Hi, this is Jeremy James, plant physiologist at the Eastern Oregon Ag Research Center, and I'm here to present an Ag Minute. More money is spent on the management of nitrogen than any other plant nutrient. Too little nitrogen in natural managed systems limits yield, while too much nitrogen can negatively impact yields as well as the environment and human health. This week, we explore why nitrogen can have large and contrasting impacts on ecosystems, and the importance of nitrogen management. There is usually very little nitrogen available to plants in soil in natural systems. This is somewhat ironic given the fact that 80% of the air we breathe is nitrogen. Nitrogen gas in the air is held together by very strong chemical bonds, which plants can't break, and they are therefore unable to tap this large source of nitrogen. This conundrum presented a severe limitation to crop yields for centuries. During WW1, a historical technological development would change agriculture forever. During WW1, the Germans were quickly running out of the necessary chemical salts to make munitions. Germany had previously imported Chilean saltpeter, a sodium-based nitrous salt, to make explosives. As natural deposits of this material were depleted, the Germans had to find another chemical source for their munitions. Two German scientists, Fritz Haber and Karl Bosch, developed a method to convert the nitrogen gas in the air into a nitrous salt. This was no easy feat. To do this, they had to mix nitrogen gas with hydrogen at 1,000 degrees Fahrenheit under very high pressure, about 3,000 psi. The end products were used for munitions. Without this process, Germany would have almost certainly have run out of munitions by 1916, thereby ending the war. This technology, however, also provided the ability to manufacture nitrogen fertilizers and paved the way for significant increases in crop yields. Join me tomorrow when we discuss the positive and negative impacts of this technology on ecosystems. Given the fact that natural ecosystems are limited by nitrogen, this technology clearly had huge implications. The Haber process now produces 100 million tons of nitrogen fertilizer per year, sustaining food production for 40% of the Earth's population. This does not come without serious environmental consequences. Currently, about 1% of the Earth's annual energy supply is used just to manufacture fertilizer. Fertilizer transport and application costs add even more to world energy use. Beyond the energy concerns, high nitrogen applications can have deleterious effects on ecosystems that normally have low amounts of nitrogen. Excess nitrogen addition also can negatively impact crop yields and human health. Clearly, nitrogen fertilizers are an important tool to sustain food production, but require careful management. We'll explore the need for careful fertilizer management tomorrow. This is Jeremy James. Thanks for listening. Hi, this is Jeremy James, plant physiologist at the Eastern Oregon Ag Research Center, here to present an Ag Minute. Yesterday, we talked about how fertilizer technology has been a critical advancement in increasing food production globally, but that there can be too much of a good thing. Over-fertilizing can severely impact the environment, crop yields, and human health. Dose-response experiments are conducted by adding various amounts of fertilizer to a crop and seeing how it affects yield. What we typically see is that increasing rates of nitrogen addition increase crop yields to a point. After that, yields level off and then even begin to decline with further nitrogen addition. These experiments allow researchers to determine optimum fertilization rates. Fertilizer rates above the optimum amount have two negative consequences. First, they decrease the health of the plant by increasing susceptibility of the plants to disease and environmental factors such as wind. Second, excessive rates of nitrogen addition means a lot of the nitrogen is not being taken up by the plant, and instead is being lost from the system. Tomorrow we will explore how losses of nitrogen fertilizer from agricultural systems negatively impact the environment as well as human health. Yesterday we discussed the importance of careful nitrogen management in agricultural systems. Applying nitrogen above an optimal rate for a crop means lots of nitrogen is leaving the system, which can have serious negative effects on the environment and the health of humans. U.S. croplands receive about 21 million tons of nitrogen fertilizer every year, but only about 14 million tons of nitrogen is harvested. This means over 7 million tons of nitrogen fertilizer is lost from U.S. agricultural systems every year. When this nitrogen enters natural systems, it can facilitate the spread of weeds, and it can increase the susceptibility of native vegetation to disease. Nitrogen that gets into streams and lakes greatly increases algae growth. Oxygen in the water is depleted as the algae die and decompose, creating a dead zone, killing fish and shrimp. The Gulf of Mexico is one of the largest dead zones in the world, created by nitrogen pollution in the Mississippi River. Nitrate, a form of nitrogen fertilizer, is monitored in groundwater because excessive levels of nitrate in drinking water can interfere with oxygen transport in the bloodstream. While the negative effects of over-fertilizing are apparent, nitrogen additions are a critical aid in global food production. Careful management and thought of nitrogen application is needed to successfully balance these trade-offs.